All right, so welcome back, everyone, and welcome to another CS 199 EMP session. So today we're going to be talking about linked lists, hashing, and maps. So it's going to be a really good session with some review, but mostly some new content right here. Right, so as always, you can follow along using the website, the playground on the website, and using the slide deck that we have on the 199 website. Let me just pull that up here. Yep, so that one. So our first topic for today, we're going to be talking about linked lists. So we spent all of the last session talking about linked lists. So this will be mostly just kind of a review, other chance to work on some new loops and linked list loops. So I think you'll find it to be helpful. So remember that we have typically two kinds of linked lists. The first one, is a singly linked list. There's one kind of arrow between each item in the list. And then in the doubly linked list, you have kind of two arrows between every item in the linked list. Of course, there is another kind of linked list that it's not mentioned here. There's like circular linked lists, which are just linked lists that have pointer back from the last element back to the first element. And then remember that each item in the linked list typically has like the item value, which is in this case their numbers, and then a pointer to the next item in the linked list. There's different variations of this. You can have multiple values in it also, but that's the general idea, right? You've got some information that's stored in there and some sort of reference to another item in the linked list. All right. So that's kind of the quick review. So linked lists are essentially just a different way of implementing the list data structure in general. And another kind of list data structure that we looked at were like array lists, right? We compared them in our last session. I looked at which one had better performance for certain operations. Let's do kind of a review on that and talk about why you'd want to use linked lists in certain situations and why you'd want to use array lists in other situations. Okay, so here are some of the main operations that we'll ever do with lists. So can we maybe, if we guys scale up to it, tell me what the time complexity would be if you try to insert something at the beginning of an array list. And then maybe compare that to what it would be if you tried to insert at the beginning of a linked list. What would be the big O notation for that? Any ideas? Right, it's O of 1 and constant time for linked lists. Because linked lists, of course, if you guys remember our last lecture, you don't have to move all of the elements over 1 in order to create a new element at the beginning of a linked list. Whereas with an array list, if you were to add a new element at the beginning, or really anywhere, you have to move all of the elements over 1 in order to create space for that new element. So array list, O(n), linked list, O(1), linear time, constant time. So what about the get and set operations? If you wanted to get an element out of an array list, what would the time complexity look like? And similarly, what would be the time complexity for a linked list? Right, so it would be O of n again for a linked list. So for get and set operations, if you remember, we have the fancy like get and set, get and put methods inside of array lists that kind of make our lives a lot easier, and we don't have to like loop through anything. We just have to. It just allows us to directly access those indices inside of an array list. So that one's really fast in an array list. So an array list, it's just constant time. And then in a linked list, yes, like you said, it's O n. We have to go through every single element, or at least n elements, or n maybe less than n. And once we get to that element, we can make the get or set. So yeah, we have to go through everything. And then finally, if you were to insert anywhere else in the list, except for maybe the back of the list, let's say you were trying to insert in the middle of the list, what would the time complexity look like for an array list versus a linked list? Mhm. Insertion everywhere or anywhere is O of n. To find where insertion is, yes, yeah, you're right, and that's a good distinction to make there. To find where the insertion is, you have to do O of n. The actual insertion is O of 1. And that's the same for both an array list and a linked list. There's a typo here, but since we're looking at it big O notation wise, it's kind of what is the upper limit for what this will take. And the upper limit is, of course, then O of n, which is the bigger of the two. So really, the actual insertion step only takes O of 1, but if you want to find where to insert, then it's O of n, because in the array list case, you have to traverse through all the elements. In the linked list case, it's the same thing, right? You got to traverse through all the elements. There is one exception to this rule for linked lists. If in the case of a in the case of certain types of linked lists that have pointers to not just the front of the linked list but also the back, then you will have constant time. You're able to achieve constant time for adding to the end of the linked list. So that is one caveat there. Linked lists, if you implement them specifically so that you have a reference to the last element in the linked list, then they can adding to the last element, so adding at the end is constant time. Okay, so we did some of a review on the performance analysis. Now let's try to do a problem. And this will be a relatively easy problem to do. It's a simple traversal thing. So we're going to give you a linked list implementation on the next slide. You can use this implementation. Create a method called getLength, which will return the length of the linked list, and analyze the time complexity for your solution. We'll do like 5 minutes for this one. Super easy, I think. And then if you run it, it should return 3. If you just copy this code, it should return 3 from this one line of code. Okay, so let's regroup at 6:18. Okay, so it's been about 5 minutes, I think. Um, let's do this. Okay, so I just, oops, I don't mean to do that. I'm gonna copy this over. Okay. All right, so if you want to do a get length method, it's pretty straightforward. Like it's just you need to figure out how you're going to iterate through that loop or walk through it, I guess. And you also need some sort of counter to keep track of the size of the linked list. So let me do a scan. Okay. And remember that in this linked list implementation, we have a start variable defined for us that we can access from within the class. So we can just do this start. And then I'm just gonna do a while loop that will continue on the reference to the item is equal to number. So this will basically loop until the very end. It'll stop once you reach the end. And then I'm going to increment the counter while I go through the loop. And I'm going to use the top manifest to go to the next element. So remember that when you're doing this, you don't really need to do like functions, like parentheses, like functions. I see some students get that mixed up a lot. So just dot next. And then you can do return dot length, return dot counter. And you're returning the final length that was. And then let's see what it outputs if we were to run it. Did before mismatched. Something is mismatched. Lessons parentheses and a semicolon. And we have some spaces in the beginning. All right, so now it's printing it as it should. Okay, so that was kind of easy. Now let's look at another problem. Well, this one will be, I think, a good one for you to just practice. Oh, sorry, I missed this one piece of the question. What is the time complexity for the solution? So for this, any ideas on what the time complexity is for this? Yeah, exactly. And that's just because you have to iterate through all of the elements. I think this is going to be consistent for any output pretty much. I mean, any input, you have to iterate through all of them. Okay, great job. So now let's look at the second problem. This will be a good one to review for the quiz today, I think. It's very simple also. Create a method called findIndex that will take in an integer argument and return the index of that argument in the linked list. If the argument does not exist in the linked list, you should return -1. So giving you some examples here of valid inputs. So these three are valid inputs that you could have, and then this is an invalid one. And you can reference this linked list solution. In fact, yeah, you should use this. It'll give you good starter code to work with. Okay, take 5 minutes for that one. Keep it 6:18. again. Sorry, 628. Okay. It's 6:28. Let's review this question. And I will copy this over. All right, so for this one, also returning an integer, takes in an argument, an integer argument, which will be the number that we're trying to find. So I'm just going to use how to sort of keep track of the index, and then we're going to use the start again. Okay, and then the loop for this one will be pretty similar. You're just going to keep looping until you reach the end of the linked list. So again, I will type at all. And what you can do is you can just do index plus plus, because once you've entered this loop, then you want to say that the index is now 0. So if you're at the 0th element, you want to check to see if the value of the 0th element is equal to the number that you are searching for. If it is, then I'm just going to break. You can break or you can return in there. Not index, let's just return index. If you never enter this, I guess this if statement here, you can just return -1, right? Because if you never enter this if statement, we know that you never find the value that you're looking for inside this linked list. So that's one way to implement it. There's some other ways that are slightly different, but they have the same like idea of traversing through the linked list and doing a check. Let's see if it works. So I'm missing a semicolon here. Oh, my bad. Sorry, I forgot to do the next thing. So you always want to do that. I equals I dot next. I didn't know how to explain how I knew that, but I just looked at when I saw the time that I knew that something was wrong with my loop, right? And I immediately knew that I had missed that. So looking to understand what happened there. So yeah, it looks like we're returning the right thing. So let's just comment these two out just to make sure. Yeah, so it's 1 if you look for the index of 1, it's 2 if you look for the index 3, it's 1, or it's 0, and then this one is -5. Yeah, this one's very similar also. You just have to remember how to keep track of kind of an index. Okay, cool. That's it for linked lists. You guys are probably tired of those now, so let's move on to hashing. So hash values, hash codes, and digests. So what are they? They are all three different ways to say one thing, which is really just hash values is, I guess, the easiest way to say it. Some people might just call it hash code. Some people, I know digest is another word for it, but it's not as often, it's not used as often as the other two. So this has to do with cryptography, and how are you going to kind of map any kind of input into like a fixed size values. So it's useful, and we'll get into the useful part of it. It's useful just because you can translate pretty much anything into one stable format. And we have a method inside of Java that does this for you with any Java object, right? So this is a string. And so with strings, you can easily convert that to hash code using .hash code. And then you can also override the same method, which we'll take a look at in just a second, how you're going to do that and see what the result will be there. And then, yeah, so they have to be uniform and deterministic is another thing. So just keep that in mind. Kind of these are three requirements that you need. Kind of is it maps to a fixed size value, uniform. The function should be uniform, as in the function that will take in the input and produce the hash code. So the function for hashing should be uniform and deterministic also. There's some key things to keep in mind there. So they're used very often, right? And this is, I think, the more interesting part about it. Really, you can use it. It's used a lot in like data integrity, kind of making sure that one state in data hasn't been manipulated or changed. Verifying downloads. So if you've downloaded anything off the internet, you've seen some sort of hash method there. If you're using Git, that uses hashing. Git uses hashing to see if there has been any changes in what you're working on. So it'll hash those values and compare them to see if what are the changes, and if there are any changes, and it documents those changes, and you can push them to GitHub or wherever. And then also Bitcoin mining, which I don't know much about, but I know that he talked about that in the lecture. So if you're interested, go check that out. Yeah, but hashing is very difficult to do. If you are trying to map anything into into a different version of itself that has a fixed length, is uniform and deterministic, and has very small number of collisions. So collisions are, of course, referring to the times when two things will result in the same hash, even though they're different. And that is very tricky to create that on your own, which is why no one will ever tell you to go create your own hash method, because it's incredibly hard to do and it's very easy to break most of them. Sorry. And if you're interested in any of this kind of stuff, there's cryptography classes that you can take, but also I really enjoy computer securities. Has some good MPs on it. So if this is something you're interested in, you gotta check this class out, CS 461 computer security. Okay, so let's do a problem. So let's imagine that you're a security engineer and your job is to ensure that there's data integrity sent between users on an email platform. So Alice is one of your users, and she's sending a super secret message to Bob, another user. And you have a third user in this situation whose name is Malicious Mallory, and she's trying to intercept and manipulate the message that's being sent between Alice and Bob. And your job is to develop a way to detect whether the message that Bob receives is legitimate. Okay, so this is kind of a good example of, this is what is called a man-in-the-middle attack, I believe, because Malicious Mallory is kind of in the middle of Alice and Bob trying to potentially manipulate this data. And this is a good example for when you would use hash codes and hash functions. So here's kind of the problem for for hashing problems. So we're going to create a class called email that has certain attributes: the sender, the message, the receiver email. And then you're going to create a constructor for that class, and then create two identical instances of Alice's email to Bob. So the message inside the email can be anything you want. I just want to see like you creating a constructor for it and then creating two identical instances of it. So it has the same sender, the message, and this email, receiver email. And then you're going to use like the generic hash code method provided by Java um, to hash both of the instances of Alice's message and see if they match. And then finally, you're going to override the hash code method and create a new way of hashing using all three of these things. So these are going to be the unique identifiers kind of here. You're going to hash the email method, the email class using all three of these things, and see if the two identical instances of Alice's message to Bob is if they match, if the hash codes match after that. So I know there's 4 steps here, but I think that should be fairly straightforward. We'll do 5 minutes for this one, actually, not 10. Yeah, let's meet at around 6:45. Okay, so it's 6:45. We'll go ahead and get started on this. So we asked you to create a class called email, public class email, and it would have certain attributes like sender's email, the message, and the receiver's email. And then we also asked you to create a constructor for that email. Strings that sender email, that message, and that receiver email. And then we can just put all of those things in here. And the reason why we actually create the constructor is because we wanted you to create an identical instance of the email methods for a class, two identical instances of email. And that way just make it easier. Here is the size in there. And give it data type. Everything needs a data type. All right. Okay. All right, so now we have a good complete class. Now we want to create two identical instances. So that will just be, we'll call this email new email. And we'll just do the sender's email of Alice. The message will be hi. Well, make sure you do with double quotes. I didn't say earlier. I think it should be in double quotes. Hi. And then the receiver's email would be just, right, I'm just simplifying it here, and then I'm going to create another instance of the same email. We'll call this email 2. Email 2. And they're both essentially the same thing, right? We just have two different instances of it. And now I'm just going to use the default hash code method to print the hash code for each of these. So I'll just be system dot so when you guys did this, did you get the same hash code for both of them? Or did you get these? When you were splitting this code with the generic hash code? Does this result in the same hash code or different ones? Right. Yeah, they're different. And this is a problem, right? Because they're really the same thing. They're the same material, same email. So if we were trying to see if these two emails were the same or have they been changed in any way, this would not help us really. So that's why it's good to override this method inside of your class. And visit public int hash code, and then you can just define how you need to distinguish between two classes and objects. And the reason why Java thinks that they're the same, that they're different, is because it doesn't really know. It just looks at the references, right, probably, And it's probably like, oh, these are different different objects. They're not the same thing. It's not pointing to the same thing. I wonder if I did this, what it would return. I just said this is equal to email. Right. So yeah, no, so yeah, I do think it's because of the references then. If I had another pointer, sorry, another reference to email, so email 2 is a reference to email 1, so they have the same hash code. Makes sense. Right, and then this is a very simple thing. You just you actually need the objects import. So like import java.util objects, and that's just a really simple no. And then once you do the hash code, you can just do hash object objects hash, and then you would give it the 3 things that you want to use to create your new hashes. Then Java knows that if 2 instances have the same sender email message and receiver email, then they should have the same hash. Oh, another public Java. Okay, yeah, so now Java is like, okay, these are, sorry, not what I wanted. Where is the empty return statement? So now Java is like, okay, you have the same sender email message and receiver email, so then you need to have the same hash code. So that's it's all about hashes and hash codes and why they're important. Now we're going to move on and take a quick look at hash maps and maps in general. I know that you guys just covered this yesterday. I do think it's still on the quiz today, so if you haven't looked at it very much, then I would. So they're really just, mappings from one key to another value, just like you would see in a dictionary. So you have a word inside of a dictionary and you have the definition associated with the word, which is why they're actually called dictionaries in Python. But yeah, we'll just call them maps. You've probably seen them already in MP2, I think in the client.java file, it's there. And you're using the map to kind of get some summary objects and some course objects and things like that. And then we'll just jump right into the practice problem for this one because it's probably still fresh in your minds because you guys just did this yesterday. So here is the problem for maps. You're going to be creating a method called word count that will return a map with the key of string and a value of an integer. And the key will be each of the strings inside of the given array, and the value will be the number of times that that string appears in the array. So here's some example cases. So you have 3 unique strings and they only happen 1 time. So they're mapped out like this. Here you have 4 of the same string, so it's just C and then F. So we'll do that one really quick for 5 minutes. And we'll regroup at 7. Okay, so it's 7 o'clock. It's nothing quick today, but we started a little bit late, so okay, so let's go ahead and start implementing this out. So we have a method called word counts, and that's taken a string array, which we just call args. Okay, and we're asked to return a map. So I'm going to go ahead and create my map now. And okay, and since we've already given you what the types will be, we will do this piece of it. And then what I'm gonna do is my thinking is I'm gonna just loop through the array of strings, for strings file inside of arg. So this is just like the enhanced for loop because we can do this. And just check to see if this value is already inside of my map. And you can do that using contains keys. And if it does contain the key, then I just want to increment the current value inside the map. If it's not, then you want to add to the map. And that's a little easier. It's just like one line. So there's a pattern. If you're not familiar with the Java documentation for this one, I would definitely look at it. It's very useful and helpful. There's a lot of methods that might even simplify this whole process for you. So I'm just going to put this value in there. I'm going to put this key in there. So the key will be actually called value. Oh yeah, that's confusing. So let's call this key because the strings are the keys. And we're going to put the key in there and we're going to give it a value of 1 because it's the first time we've seen it. And for the incrementations, so if we have a key already inside the map, then we can just suspect what key is, or the value of that key is. It's not in none is equal to map get key. So the get will return the value of that key, and then you can do map dot put, and then you can put the key in there, and now you just do num plus 1 because you just want to increment by 1 because now you're looking at another instance of that key inside of your original strings array. I'm seeing all sorts of things today. And then you can just return your map. I think you have to import something here. Let me import statement. Java. Okay, I'm just going to import all of it again. And sorry, should be hash map. Yeah, it should be hash map, by the way. contains the I think it's hash map. I'm not sure. Let's see. This works. Oh, also need to import some map here. Okay. So what do we look at here? We demonstrated the use of contains key. We demonstrated the use of the put method and the get method, which I think are kind of the main ones that you need to know. If you don't know the other ones, there's some handy ones that are like get, default, get or default, and things like that. But for default, which you can use if there's like no current key that you're looking for. These are like the main ones that you need to know. Anything with maps, but they're really useful. You see them used all the time and pretty much everything actually. Um, yeah, so that's all for today's lesson. Thanks for coming by. Do appreciate you taking the time. We looked at linked lists, we looked at hashing, we looked at maps. Next time we might do some more stuff with maps and some exception handling. But good luck on the quiz today. We will see you next time. Bye.